let's say that 12 eggs is equal to 1 dozen. 1 dozen eggs is equal to 2 cows, and 1 cow is equal to $100. Yeah. Alrighty.
$200 per dozen.
Where's the golden goose?
Okay, we're going to change this a little bit because this is kind of ridiculous. What if you could buy... Yeah, 12,000 dozen eggs. Okay, that no way. Let's see. Yeah, 12 dozen eggs is equal to 2 cows. Okay. Yeah, we could simplify these ratios and go, well, that means 6 dozen eggs is equal to 1 cow. But let's ask the user for the dollars and tell them how many eggs they can get. We could just do what we drew on the board, long form, or we can write out some rules. If, okay, we're going to write out our rules based on these facts, so I'm just going to copy these facts again. If we have 12 eggs is equal to 1 dozen, then that means, how do you calculate dozen? Dozens is equal to eggs times 12 or divided by 12? So that's divided by 12. And that means that eggs is equal to dozens times or divided by? Well, it'll just be the opposite, right? But if you have 2 dozen eggs, that's 24 eggs. So we're going to multiply it by 12. Those are our 2 useful equations out of that bit of data. Here we go again. We have 2 useful chunks of data. I think I'm going to simplify that just because it's easier for my brain to work. I'm going to change 12 dozen eggs for 2 cows to 6 dozen eggs for 1 cow. That means that if I'm trying to calculate the number of cows, the cows is equal to the dozen divided by 6 or times 6? Not sure about that. I think it's divided by. Because if you have 1 cow and it's 6 dozen, that means that if you have 6 dozen cows...
Would it be dozen times 12 because you're multiplying the number of... No, you're dividing the number of dozen. No, hold on.
Yeah, okay.
Multiply dozen times 12 because that goes to how many eggs you have.
Right. So it's divided by 6. And that means that a dozen eggs is equal to the number of cows times 6. You just have to kind of lock in to whatever makes sense to you. Whichever one of these is easier to figure out first, you can figure out the opposite really fast. You know, if it's easier for you to convert from cows to eggs in your mind by multiplying, great, and then do the division. Okay, lastly, we have cows is equal to dollars. I'm going to rewrite that to the word dollars. So, dollars is equal to cows divided by 100 or multiplied by 100? If you have 1 cow, each one's worth $100.
So cows divided by 100, or no,
Times 100, right. Each cow is worth 100. Then you could write that backwards. Cows is equal to dollars divided by 100. Now with that information, we could convert from any one of these units to any other unit. We could say, ask for the dollars and say how many eggs. Or we could ask for the eggs and say how many dollars. Which one looks more fun, A or B? The answer is you don't really care. Neither do I. Okay.
Half a dozen in one hand, 6 in the other.
Yeah. 6.5 of one, half a baker's dozen of the other. Alrighty. So here we go. Here's our 3 rules. Let's say that we're going to, or 6 rules actually, but let's say that we're going to ask for the number of eggs and figure out how many dollars. Pardon?
Did you say half a baker's dozen?
Yeah. A baker's dozen is 13, so half a baker's dozen is 6.5. I know, it's stupid. Okay. So Here we go. If we ask for the eggs and calculate dollars, we're going to input eggs. We're going to output dollars. We need some conversions. Given the number of eggs, what conversion can we do? All we can do is, we only have one out of these possible 6, which is good. And what do I mean by possible 6? We have 2 rules there, we have 2 rules there, and we have 2 rules there. Which one of those would be applicable to converting eggs to something?
We have to convert the eggs to cows and then the cows to dollars, or?
Something like that, right. But which conversion do we actually have listed in our 6 rules?
The eggs to dozens.
Eggs to dozen. Okay, so dozen is equal to eggs divided by 12. You see where I got that? Now I want an equation that plugs in dozen on one side and calculates something else. Which equation can I use there?
We go with the cows.
Cows is equal to dozen divided by 6. And then lastly, we're going to want to put cows on the right-hand side. So which equation are we going to use?
Cows times 100.
Yep, cows times 100 is equal to $1. All right. Although this is a silly program, let's go ahead and implement it. Pop open idle, file new, and this is our calculator.
Oh, wow.
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 That's funny.
I'm pretty proud of that one. Okay, so, or I'm ashamed, I'm not sure which. We're going to input the eggs. So, eggs could be integers or floats. It doesn't really matter. Eggs is equal to I and T. We're not going to let them type in 12.5 eggs. If they do, it's going to crash. But let's do the input first. Eggs is equal to input. How many eggs you got? Then we need to convert it to a number. So eggs is either equal to int or float. Why not float? That way it won't crash if they do type in a decimal. Eggs is equal to float eggs. We have our data. We can do these 3 conversions. I could just cut and paste them. A dozen is equal to eggs divided by 12. Cows is equal to dozen divided by 6. And dollars is equal to cows times 100.
Question.
Yeah.
Is it going to throw an error if they don't have a full dozen of eggs?
I don't think so, because we made it a float.
Okay.
Let's type that. Let's type in like 0.1 egg and see how much that's worth.
Well, no, I'm just saying, like, if you have 1 eggs, it'd be 1 over 12 dozen.
In other languages, that would be of serious concern.
Okay.
Because if eggs was an integer and you divide an int by an int, it rounds down, and then we would wind up with 0 dozen.
Okay.
But Python isn't so picky. So, and also we're starting with a float, so it's going to result in a float no matter what. So we're good.
Okay, just check.
We can convert them cows to $, comma, dollars.
Don't we mean eggs to dollars?
Yeah, convert them eggs. So it should have been an eggculator. That sounds like something out of Willy Wonka. Okay. Egg equation.
So I promised him I would do this, and I came a little late. Are you recording, and do you have the microphone on?
I have the mic on.
Are you recording?
Am I recording? I see the C here. All right.
Okay, good. One of the gentlemen had a funeral today, and he asked that I make sure.
Yeah, thank you. Okay. So calculator, or the egg equation. Here we go. I have 12 eggs, which we can sell for $16. That's plausible. I would have to work that out the long way to see if that was accurate. Maybe we could eyeball it. Yeah, I'm going to eyeball it, and I'm going to show you what I mean by that. If you have these equations here and then you want to shorten them, it's not too hard. I'm going to paste them down here. Don't type them in. But if dollars is equal to cows times 100, what is cows equal to?
Dollars divided by 100.
Well, what I mean is based on this set of equations. Cows is what? It's dozen divided by 6. So I can just paste that there. Now, what is a dozen equal to? Eggs divided by 12. Okay, so that's a short form of the equation.
And 12 divided by 6 is 2.
Right, I could certainly simplify that. What I did is I redid the conversion. You don't have to type it, so I'm reprinting it just to see if both of those come out to be the same. I have 12 dozen eggs. I can sell them for $200. Okay, so that worked. I had a print statement here and a print statement here.
Okay.
Yeah. Alrighty. Hope that makes sense. I've given you all sorts of tools for doing this. More than you want. Here is the assignment based on the idea of conversions. And in a way, they're just little logic problems more than anything else because it's not using any capability of Python that we don't already know. So here we go, our conversion problems. Write code that will solve the following 3 problems. Tribbles for the Star Trek fans. 1 bar of gold pressed latinum is worth 20,000 credits. Say a tribble is worth 10 credits. Write a program that will ask the user how many bars of latinum they have, and then display how many tribbles that would buy. If you don't know what latinum is or tribbles, it doesn't really matter. These are just units of something. That's worth 20,000 of them, and a tribble is worth 10 of them. So that would be your intermediary unit. Here's how it could run. How many bars of gold-pressed latinum do you have? 3. Great news. That'll buy you 5,600 whatever triples. That number is totally incorrect. I just typed it in at random. And you could round that to a whole number.
Let's just say, do you want us to round to a whole number?
Feel free to. Yeah. I think it'd be fair because if you sold somebody half a triple, they'd be upset.
Well, they could use it as 2 day.
You like bathing in a bathtub?
Yeah, you like bathing in a bathtub of milk. I mean, who doesn't? The bathtub holds 40 gallons. The cost of milk is $3.85 a gallon. You always discard the milk after each bath because that would be gross. Ask the user how many baths they want to take, calculate how many gallons of milk, and how much it would cost. And again, these numbers are totally made up. How many milk baths do you want to take? 7. That'll take that many gallons and that many dollars.
So, do you have how much the milk costs?
I hope so.
I think it says 385.
Oh, 40 gallons and $3.85 a gallon. Right. All right, and the last one. Sugar or sugar addict. A pound of sugar has about 1,750 calories. It is generally accepted that 3,500 unburned calories can cause a pound of weight gain. Ask the user how many pounds of sugar they eat in a day. Well, personally, I eat 12. And display how much weight gain that causes in a week. So there's an extra conversion in there that you'll have to manage, that there are 7 days in a week. How many pounds of sugar do you eat in a day? 5. If you do not burn that out, you might gain that many pounds in a week. And again, that number's made up. What did Drew Carey always say? Where the questions or whatever and the points don't matter. Okay, anyways. So, that is the assignment. This one's the simplest because it's just like a 2-step solution. There's only 2 factors. There's 1 intermediary. This one's just about as simple, except I ask you to print the intermediary, which is gallons. This one actually has 3 conversions. It has a pound of sugar to calories, it has calories to a pound of weight gain, and then it has a week is 7 days. So, a little bit more, but not much more. I think y'all can handle it, but if you get stuck, ask me, text me for help, I'll be glad to give you equations that do this, but I want you to take an honest stab at it yourself first. A question comes up is how could you format this data to be better than 7.60141? And the answer is that the print statement supports something that you may have seen in C or Java, which is a percent syntax, where you can specify the format of what you're printing out. I need to turn this light down just a little bit. So we're going to modify our program, our calculator.
But, there's something going on with my network connection. Why is this going on? So I might just switch computers.
Oh boy.
I didn't even notice that until I started it out here. And I was like, oh, what's going on? So,
My guess is that there's a cable unplugged. If you're on the network and she's not,
That's what it is.
first rule of tech support. Unplug it, plug it back in. See if it's flickering.
Flickering is connected to the line.
yeah, I was thinking about that. I was like, maybe I should just, I saved it on my flash drive anyway. So
Yeah.
just go on the other computer.
You reboot it, it might magically fix it
Maybe.
or reset it.
Okay.
All right, I'm going to show you a snippet of Java code. There's absolutely no reason for you to write this down. But say you have this. I have a double. I'm going to call the variable d because in Java you have to declare your variables. And it's equal to 1.0 divided by 3. And then I do system.out.println d, which is just like our print statement. What it's going to print is 3. And then who knows how many 3s it's going to print after that. Probably about 14. What if we wanted to force it to print it out as 3.33? We can do that. We would not use print line. We would use a very similarly named function called printf, system.out.printf. And we would say, here's my formatting string. The percent sign means, oh, by the way, this is a placeholder for my data. It's floating point, so I'm going to put an F there, but I want 2 places after the decimal point. And I want it to go to the next line, so I'm going to put a slash in there. This is a little bit more than what we have to do in Java, but it's in Python, but it's very similar. So, and then we could print out D like that. What if we had we had 2 numbers we wanted to print out. For some reason we had an integer named x. And we wanted to print that out, and we wanted to print D. But we wanted X, for some reason, to occupy 5 spaces on the screen, not just 1. We could use another printf, system.out.printf, and we will get back to Python in just a second. %d, because it's an integer, it's a decimal, but we want it to fill up 5 spaces. And then %.2f, and a slash n to go to the next line. And we're going to pass in X, and we're going to pass in D. What happens is when this is running, this is a formatting string. It says one of these arguments is an integer, because the D means integer. I wish it was I for integer, but it's not. And when you print this out, please format it to fill 5 spaces on the screen. So it's going to pad it with 4 spaces to get that to work. And then, okay, the next thing that's coming up is a floating point value, like a double. That works perfectly. And I don't care how many spaces it fills, but I only want 2 decimal places after it. So when this printed out, it would print it like this. We said we wanted 5 spaces. The value is 3, so 1, 2, it would print it out like this. 1, 2, 3, 4, 5. Now that filled 5 spaces. Then there's a space here, so it would add that. And then this says I don't care how many spaces, but I only want 2 decimal places, so it would print out 3.33, like that. not how you do it in Python, but it's very similar syntax. You use a percent sign. I'm going to go to the Python shell, and we will play with this. So if x is equal to 1 divided by 3, let's print x. That's too many decimal places. My customer doesn't want to see 15 threes. So print percent dot to f, end quote. But instead of separating with a comma like I showed you in Java and how we've used in all of our other print statements, we use another percent sign. So it's going to be print, parentheses, quote percent dot to f, into parentheses, followed by that percent sign, followed by the variable we're trying to print out. And it prints it out as 0.33. Why do you like that? Well, because if you're printing tables, you want to restrict the width of your columns, or else they're not going to line up. Let's write a new program that prints out some kind of multiplication table. It's going to use a doubly nested loop. It's even going to use range statements. We're going to go nuts. Alrighty. So for x in range, we want this to count up from 1 to 10, but since I want it to stop at 10, let's just go to 9. So 1 to 9. Why do I say 1 to 9? Because it stops before it hits that number. So this is going to execute the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Now inside there, let's do another loop. For y in range, 1 comma, we want it to go to 9, so I'm going to go 1 past it, 1 comma 10. Now let's print out x times y. Oh, and here we run into a problem. We haven't seen how to print something where it doesn't automatically go to the next line every time you print. I'll show you what I mean by that. Let's just go ahead and run this and watch what happens. I'm going to save this and call it, save it in my scripting folder and call it table.py. This isn't going to work at all. Why? It just gives us a straight series of numbers. That's not cool. What we need it to do is to print numbers and not do the carriage return after every number. You can convince it to do that with an end parameter. You say end is equal to, and then you give it an empty string. By default, there is an end parameter, and it's equal to /n. So every time it prints, it terminates the printing with a /n to go to the new line. That's what /n means. But we don't want it to go to the new line every time we run, every time we print something. We want it just to sit where it is, waiting for the next print. This still isn't going to work, but hopefully it's closer. Ew. Excuse me. Is it not end?
I think you need a comma.
Think I do? Okay. Yeah. But it printed them all out in one big row. What would be better? Well, for one thing, we need spaces. So we could just do 1 x times y,
Space, comma.
comma, empty string, comma, end is equal to empty string. That's looking better. But we need to go to the next line after every row. This is printing out a row. This is printing out all the columns. So after we're done printing out columns, we want to go to the next line. There we go. That's looking a lot better. That's almost what we want. But what could we do to make it better still? We really want each one of them to occupy the same space, right? Otherwise the columns are never going to line up. That's going to take a little bit of modifying. Hopefully not too much. I'm going to comment this line out because it was a good stab.
So what's that print, that second print statement that you have? What exactly is it?
Here, let me put something in it. Like Bob. Why did I put that there? It just shows you where. Oh, come on.
Because you, yeah.
All right, you see what it's doing? We needed it to go to the next line. So we put a print statement there to force it to go to the next line. Without that print there, if we comment that out, it looks like this. Does that make sense? So that loop counts it from 1 to 9, and then we needed a break. So we just issued a print statement.
I'm gonna comment that one out.
Okay. I think I'm going to copy this and paste it rather than erase it. I mean, change that line. Copy, paste, but we are going to change this line here. Here's what I want to print. Print, quote, %2D. Make this number occupy 2 spaces. Pad it out so that it equals 2 spaces. And if I was going out to 10 by 10, I'd want to pad it out to 3 spaces because the last one would be 100. And then put a space between everything, even if it filled up all 2 of those.
What's the symbol next to 2 again?
That is a %sign, which is just Shift 5.
Okay. Sorry, I just.
No problem. I know you can't see the. That's not the worst, you know. Like, what is that? Oh, eventually you learn that's the vertical bar, which is a Shift backslash. But okay, we're not going to be using that one. But we will use this, X times Y. There we go. And I still think we're going to need that end parameter. Let's run it and see what it does. Well, that's cool.
It's cool, but is it really what we want?
What have I done?
That is awesome.
Okay, here's what I was expecting to have to do, is to put a comma, end equals empty quote there.
Well, that, like, really.
Is it because I haven't indented it incorrectly? No.
You did Pascal's triangle.
Yeah. Alrighty. Uno momento. While I make random changes trying to fix it. Okay. That was odd, but you can fix it by putting this X times Y inside parentheses to force that to evaluate separately, or before anything else happens. Kind of odd we had to do that. So that's the syntax for formatted printing.
When you put that space in there, it looks really good. You put the comma, empty space.
Oh yeah?
Yeah. I think that's probably what you wanted. Now running.
Okay, yeah, that added another space to it. Space it out further. So if I was going to go out to, 12 by 12, I'd want to allow 3 characters because 12 by 12 is 144. Let's modify this so that it goes all the way out to 12 by 12. We need to change these 10s to 12s. And we need to change that %2D to %3D to allow it to fill 3 columns.
If you want it to be 12 by 12, wouldn't it be like 13? If you're not including.
You're right, it needs to be 13. You're keeping me on my toes. You're saving me from myself. Okay, I had to make that 13 in order to count up to 12. Why is that?
Because it will stop it.
because the range stops at 1 before that value. Or it quits when it hits that value. Wish it didn't. Alrighty, here we go. There's my 12 by 12 table going all the way from 1 to 144. This really would almost have been impossible to do without the formatted print statement to get it to line up like that. You could have used tabs, but the tabs would probably push it off the edge of the screen. No, even then that would, yeah, maybe would have worked, but far easier to do it that way. So to go back to our other types of problems, we were winding up with fractional numbers. So instead of using %d, we'd want to use %f. Like we have 11, or eggs is equal to 11. Dozen is equal to eggs divided by 12. This isn't going to be that impressive, but let's print that out. Print let's print dozen, comma, dozen eggs, like that. All right. Here's what I got when I printed that. I should comment out those other loops. I'm going to change those loops to only go out to 1 because they're filling up too much space on the screen. Uno momento. You don't have to make that change. Alrighty. The customer calls and complains that there's too many 6s. They only want 2 decimal places specified or printed on the screen. Yep, they're honoring. Okay, so we're going to fix that. What we're going to do is where we print the dozen, we're going to add a formatting string. So in front of that word dozen there, quote, %.2f, end quote, followed by a %sign. And it said that that's equal to 0.92 eggs, and our customer's happy. They pay us $1 million and we retire.
I got one.
So D just rounds, or what exactly?
D is for integers,
Or just integers?
and F is for floats. What happens if we mix that up? What if we try to print this dozen with a D? This is I'm kind of asking myself that rather than you. %D, %dozen. Is it going to crash? Is it going to round it down to an integer? Let's find out.
No Gilmore, 1. No 0.
It rounded it down to an integer. All right. Other languages, that would go kaboom and stop the program from working.
Yeah, if it rounds it up. It's doing.
Yeah, we could issue a math.round command and round it up to an even dozen. Or
Yeah,
we
what
could
is
do
the
this. %.0f. And let's see if that rounds it up to 1 dozen.
Yep, it does.
There we go. There. That's cooler. Rather than mixing your types. So anyways, %D, output, or for ints, whole numbers, %F for floats. You can fake an int by just saying %.0f. And %S for strings. There's probably other variants that I'm not remembering. Java, for example, you can print them in exponent form or in hexadecimal. Hexadecimals are %x. I don't know if that works here. We could try it. Out of curiosity, I'm going to go back to the shell and try that. X is equal to 3. Print %x. End quote, %x. Well, that's dumb. x is equal to 255, print, quote, %x, %x. Yeah, okay. If you ever feel like having a quick and dirty calculator to go from a decimal number to a hexadecimal number, you can do it that way.
Oh, wow. Huh.
I mean, there's two. The calculator does it for you.
Let's remind ourselves of how to round. Let's say that I wanted to round this number of dozen rather than just output it. And I want to round it to one decimal place. How do I do that?
Round.
Is there a function round, or did we have to import math? I think we had to import math. So, import math. Dozen is equal to round dozen out to one place. And then let's print that out. Should we put our import right down there at the bottom? No, but okay, that worked. Why would I not want to indiscriminately round? Well, I could introduce, errors into my program. In my mind, it's better to preserve your accuracy and then just change the format rather than change the data.
That is 0 next to the
On that one,
Yes.
yes, because I wanted it to print whole numbers only, so I said no decimal places. All right. You would think I would do a lot better job of remembering where we are in the text.
I think we were at the end of functions.
I think we were. We have used functions, correct? We've used DEF. We know what parameters are. What are parameters? If I tell you to write a function called triple that accepts parameter x and returns 3 times x, how do I do that? Well, I have to define it, so what am I going to start my function off with? DEF. I'm going to call it triple. My instructions say that it accepts a parameter, so x. Now what? A colon. All right, did we cover this, or I want to hear a yes, or are y'all remembering this from the last
I'm
class?
pretty sure we covered it, but not like.
I don't think we covered putting something in the
Okay,
setting
okay,
the parameter.
okay, okay.
We set the definition.
So anyways, and then you do, well, I could just look at our notes from Monday. Then you could do, well, okay, r for my return value is equal to x times 3, and then return r. Or do I have to do that? Whoops. I could just do this in one step rather than two. I could do return x times 3. Both of those are valid approaches. If you're doing some kind of complex calculation, it's better to store it in a temporary variable and then return that, just because it's easier to debug. You can put a print statement there. Now I am curious. Did we do turtles?
Yeah, we did turtles, yep.
And we did flowers? Okay, so here's what we did that used functions. This is making me think that we used functions, but we didn't hit the chapter. I mean, yeah, we didn't get through the chapter on it. So here we've defined a function that accepts two parameters, x and y, and it uses those to determine where the turtle is going. This function accepts two parameters, in and size. In is used for the number of petals on the flower, and size is how big each petal is. And so the way you write a function is with def, followed by the name of the function. If it accepts any parameters, you have to put something between the parentheses, else you don't. Everything that is indented is considered part of that function. The first unindented line terminates the function. You can use the word return to force the end of the function right there, but you don't have to if it's not returning anything. And our goto function isn't returning anything, and neither is flower. However, triple, which we did here, does return a value, so we use the return statement. So we know a lot of this stuff. Did we talk about random numbers?
Yeah.
So if you just call random.random, you get a number between 0 and 0.99999999999. However, if you specify a range, it will do that range. And I know we talked about that because this is one of the rare times when the range is inclusive rather than exclusive. You can also use random to pick randomly from a list. That's real useful since we haven't talked much about lists yet. Okay, so math functions we know about. You import them. Once you've imported them, if you do that in the shell, you ought to be able to get a list of the functions that are in it. Like import turtle, dir turtle, derp, okay, dir turtle, and that's not the correct syntax. There's a list of all the things that a turtle contains, all the methods you can call, and all the variables in it. Now, when we use a turtle, we're going to use about 6 of those. Let's import the math library and do the same thing. Import math, dir math. There we go. List of our members of the math class, the math library. That's a quick way to get a feel for what your import is letting you do, besides just going out and hitting the documentation, and who wants to do that? Okay, so onward. Adding new functions. We can define our own functions. Yep, I certainly remember that. The guy who wrote this was a Monty Python fan, just like the creator of the language. So there's all these lyrics to Monty Python songs. We talked about flow of execution. I think that's where we stopped. Fruitful functions versus void functions. Triple is a fruitful function. Why? It bears fruit, it returns a value. Here we go. We define another one, like say hello 3, and we're going to pass a name into it. It prints name times 3, so if you type say hello 3 parentheses Bob, it's going to print Bob, Bob, Bob. That's kind of dumb, but it doesn't return anything. It's got a return statement, but it returns nothing, so that's a void function.
Would it even work because it doesn't even call the parameter?
It uses the parameter there. Which part would not work?
Where does it get in the name? Like
Oh, well, that's true. If we're not calling it, but I didn't call triple either. You know, okay, so x is equal to triple 9. Ought to return 27. Say hello 3 Bob. Like that.
Okay, never mind.
This one called a fruitful function. So it used a variable to catch its value. Say hello doesn't return anything. In fact, that statement is superfluous. I don't even have to add it. It doesn't break it, but I don't have to add it. So it doesn't have a variable to hold it. If you want to, you could store its value in a return, but there's no point to it. I'll give you a demo. Define say hello 3. I don't know why I called it say hello. It ought to just be called say 3. print name times 3. Down here I'm going to do say3, and I'm going to pass in Bob. Then I feel like storing the result of say3 in a variable, which is dumb because it's not returning anything. A is equal to say3. Let's print Jim's name out. And now let's print out A, just because we're curious what it passed back. None. None is the value that gets returned back. You can actually check to see if something returned none. You can use that in an if statement. If A is equal to none, with no quotes, colon, print, hey, that was a void function. You cheater. Okay, that's stupid, but you get the idea. So when I run it, it's not going to say that. Or it is going to say that. Hey, that was a void function, you cheater, because it returned none. But if I change, say hello, to return something, anything, even a 0, it will not say that any longer.
None has to be capitalized.
Yes. Usually you know whether a function is going to return for a value. I've never written something that checked the return value to see if it was none. Mostly I'm doing that to burn in the idea that if it doesn't return anything, there is a special value that gets passed back anyways. And that's kind of specific to this language. It's not the way Java or C or C++ works. I should make this an else. That was a void function. Else, colon, print, function returned, comma A, like that. And make it more reasonable. So why do you have functions? It may not be clear to you why it is worth the trouble to divide a program into functions. Creating a new function gives you an opportunity to name that group of statements. Makes your program conceptually easier to think about. You can cluster parts of your code together. Also, you can make a program smaller by eliminating repetitive code. Like if we're going to perform a calculation 100 times, we might want to put that into a function so that we don't have to rewrite that calculation. You know, our calculator had like 3 conversions in it. I'm going to go back to it. If you can find your calculator again, I'm going to modify this so that it uses functions. This top one is going to be called getEggs. So define getEggs, parentheses in, parentheses colon, and I have to tag everything, tab everything under it. And it needs to be a fruitful function, so I'm going to do return eggs. I'm going to do something for the calculator. Define calc dollars. Okay, now I'm going to make a mistake here on purpose. Then I have to return the dollars at a calculator, or else why did we have the function? What is my mistake? If you can spot it. If you can't, that's okay. But this function has a bug in it. Or I won't say a bug, it'll actually be categorized as a syntax error when we try to run it. We don't have eggs anywhere. Eggs looks like it's defined up here, but it's private to this function.
Right. So you gotta make it global.
So we could either make eggs global, or better yet, we're just going to pass it in as a parameter.
That explains the parameters. Got it.
Yeah, yeah. Or you can, you're right, you can make all your data global, but that's considered really fairly bad programming unless there's a strong reason for doing that. Okay, so, and then let's put I think I'm going to get rid of that one. You saw how we use that one, but I'm going to get rid of that. I'm going to define one more called output. And we have to pass in the amount of dollars for that one to work. And I need to tab print. Now I could use good variable names or I can use garbage variable names. I'm going to use garbage variable names to begin with. X is equal to get eggs. Y is equal to calc dollars based on X. And then output Y. That ought to work. The names aren't great, but it ought to work. Well, there is now. We just made one. We use that all the time in our pseudocode. Now we actually made one. Okay. There we go. So it actually worked. If I was going to make this a better application, I would not use a single letter variable name there. I would actually call that eggs, and I would call that one dollars. The reason why I left it like that is because I don't want you to think that just because this says eggs here, that this has to say eggs. Why? Because they're not the same variable. X is a copy, or eggs is a copy of X. So it's like you make a photocopy, and then you give it to the calc dollars function, and it does something with that photocopy, and then it returns a value back. When we pass in Y, and it fills in that one, dollars is a copy of Y. It is not Y. That actually has a very strong implications. If we do this, dollars is equal to 0, and then we print Y down here, you might think, and it's a reasonable thought, because you can do this in other languages if you trick them, I won't even say trick, that this would change the value of Y. I mean, look, we copied Y into it, and now we're setting it equal to 0. By the time we get to here, won't it be 0? And the answer is no, because dollars just got a copy of the data. It's not the original variable. That is because Python is not a pass-by-reference language. It is a pass-by-value, as Java is. Both of those are pass-by-value or pass-by-copy. C# and C++ allow you to do other things. C++ lets you create pointers if you want it to be able to change the data. C++ also allows you to create references so that both of those things reference the same data. C# has that ability. You're not supposed to use pointers in C#, but you can use references. This language doesn't have either one of those. So when I run this, it's not going to print 0, even though I say dollars is equal to 0. It's still the same value, even after the function call. Sometimes that can irk you. What if you really wanted this function to calculate a value and you wanted dollars changed? What could we do if we really, really wanted output to pass back a value? Well, how did we pass back a value in these other functions?
Return.
Yeah, we used a return. You could do this, return dollars. And then down here, you could say Y is equal to output Y. That's legit. Now, for the purpose of this app, it's stupid. But we could do it. Now, when I run it, it will really print out a 0. But I'm going to undo those changes because they're pointless. It did print a 0. Why? Because it changed the value of this copy of the data to a 0. It returned that value, and that got passed back into Y with the assignment operator. But that's dumb. I'm going to take those 2 lines out. Don't need those 2 lines, and I don't need that print Y, and as a matter of fact, I don't need that either. Alright, it's back to as it was a few minutes ago. So why do you break things up into modules? Well, if you're working on a large project, you may have huge amounts of code. They may be stored across multiple files, dozens of files. You say, okay, there's a problem in the calc dollars function. Mary, my associate programmer, I want you to go fix it. She can just check out from the source control system that one specific file, make a change to that one specific function, and change it back in without threatening the rest of the code. It allows multiple people to edit the code, changing only the pieces of code that they need to work on. You can be sure that the large games, that we play on our Xboxes and PlayStations have thousands upon thousands of functions defined. And they're clustered together in the form of what are known as classes in order to provide some order to them. A class is a library. The turtle is actually a class when we do import turtle. And then when you're ready to use it, it's as easy as calling them like that. This looks pretty clean. You could give somebody this code in another file, and they could do import calculator, and then they could do these three things, and it would do all that. And their program would only be 4 lines long. It'd have an import statement up at the top, and it'd have these 3 lines. We have created an API, an application programming interface, for another program to use if we do that. So learning how to think in terms of how to cluster your code is a really good thing to do. If you can break your program into pieces and put those into functions, you're well off. Now, a lot of the code that we write in these sample things are not complex enough to warrant it. Did this really need to be broken into functions? No. Does your conversion, when you're going to calculate the number of triples, need to be broken into functions? No. But you might do it just for the practice. It's not mandatory. All right, sometimes people need to leave partway through the class. I'm going to make a Dropbox for what we've done so far. This will be G. It'll be called calculator. And equations. Thank you. And I didn't put a due date on the F. Due last week. Due Tuesday. Monday, excuse me.
For the in-class assignment, do you think you could make it, not in-class assignment, pretty much what we've done, do you think you can make it due a little later so I can get home and turn it in? Because I did it on my laptop.
Don't worry about it. I don't count late,
Okay.
on the in-class assignments unless it's egregious, like more than 4 weeks late. So don't sweat it. It may get a little red mark next to it, but I'm not going to count off for it. The in-class homework I do really want to be done on. The homework I really do want to be done on time. All right. So in that Dropbox, I'd like you to put in your calculator script. It seems like we did another one. We did the table. You may as well put that one there as well. So more reasons to use functions. It makes the program smaller by eliminating repetitive code. Well, we haven't done that yet. But you get the idea. We did that on the flower. We had 6 lines of code, but we could invoke it just with one word, and it would draw the flower. So we didn't have to keep copying and pasting. Anytime when you're programming, you wind up copying and pasting code, you probably ought to turn it into a function. If you copy and paste it more than once, if it appears 3 times in your code, then it's criminal not to make it a function. The programming police will come get you.
But I'm paid online.
Right. So dividing a long program into functions allows you to debug the parts one at a time. I could put each of my calculations and test them out one at a time. Well-designed functions are often useful for many programs. Once you write that function and debug it appropriately, you can reuse it. You know, you could put an import statement and import that, or you could copy that function into your new code. Throughout the rest of the book, we will use function definitions to explain a concept. Alrighty. What is the body? The body is a sequence of statements inside a function definition. It's whatever is tabbed, actually. A function has a body, but also an if statement has a body. The body of the if statement is the stuff that's tabbed under the if statement. What is composition? That's when you take a mathematical expression of some kind and you turn it into a code expression. So if it says 4, line 3, and then in big letters pi, you know that you're going to have to turn that into 4 divided by 3 times pi. That's composition. Deterministic. This is a good thing in most programs. If it does the same thing every time it runs, given the same inputs, that's a good thing, unless it's specifically supposed to generate random numbers. If you were playing a dice game and it gave you the same dice rolls every time, you might get bored with it pretty quickly. Flow of execution is the order in which the statements are executed. When I called, where's my calculator? When I called getEggs, it jumped up here and it ran these. It didn't really matter whether this was defined here or between these two functions or what. That's the flow of execution. GetEggs, oh, I have to do these two statements. I have to return back. That return statement fills in X. Now calc dollars, it runs up here. It runs those 3 lines of code. It returns a value, which gets copied into Y.
That would cause a problem?
No, the order that these are defined does not cause a problem as long as one of these functions is not calling the other. If this one did this, getEggs, that would definitely be a problem because it's not defined yet. If you need to get around that, that's when you use that if underscore underscore name underscore underscore is equal to underscore underscore main. And then you tab all this stuff over. Something's nagging me. Is this going to work?
Good. Do you need parentheses on the other side of me?
Yeah, why did I put that parentheses there? And it worked because it got all the way down to here before it started running any of our code. So by the time it got down to here, all the functions were loaded in memory and ready to go, so it did not matter in which order they were defined. So if you do your code like this, which is a strong argument for always doing that, then you don't have to pay attention to the order in which the functions are defined. Otherwise, you absolutely do.
Is that why it asked you twice for the number of eggs when you ran that?
No, that's because you put in a...
Well, right. I put getEggs in there, so when I ran it,
It
actually asked me twice, right.
Okay.
That's just because I put that dumb example in there. Yeah. Okay. All right. I think that's about enough for today. Plus, we're out of time, so good thing. Like I said, if you get stuck on the conversion assignment, ask for help, and you shall receive it. I will see you on Monday. Next Monday we do meet. It's the following Monday we don't. I'll be right there.